Hi, my name is Alfredo Deza and I'm a software engineer working with Anchore. We're writing a bunch of different tools with a focus on security and analysis of containers. And today I want to talk to you about a software bill of materials. What exactly is a software bill of materials, sometimes referred to as an SBOM? And in particular, there's this one tool called Sift, and that's what I will be covering today. The specifics of Sift, what involves creating an SBOM, what is it for, why is it useful. Before we go into the details of what Sift is and what it does, let me jump into the terminal. I have a personal project here. I have a Docker file. So let's open up my terminal pretty quick. Let's see, right here. I have a Flask app, Docker file, license or readme requirements.txt. This is a Python project. Let's take a quick look at my Docker file. So Python 3.8, I'm copying my requirements text over to the container and then installing the requirements.txt. We'll see in a second what's in there. And finally, I run Python and then app.py, which runs this web service. Let's take a look at requirements. Requirements.txt says that I have Flask 1.1.0 installed. So just a single dependency. Now let's take a look at the app.py. So very simple Flask application, just two functions. The function 200, which returns a string that says 200, all is good, and /error saying, ooh, there's some error. So pretty straightforward, nothing weird, nothing complex here. It installs Flasks and run this small app.py file. Let me quit out of there. So if I build this Flask application, actually let's just do that right now. If I say docker build -t, I'm gonna say Alfredo Deza / Flask app, and the context is the current directory. So let's run that. And so that will pull the Python container. It will install my requirements.txt. We see that going on there, and then that's good. It's all done. And so docker.io Alfredo Deza Flask app is done. So if I run it, I can interact with it. Docker run -p. I think it's 5000, the port that I have exposed. We can say like that. I think that should just bring up the container. Well, I have something else running there on port 5000. We can change it to something else. Let's say 5010. Perfect. So now this container is running. I can interact with it. That's perfect. And only Flask at version 1.1.0 got installed. It is good to go. So what is the deal? The thing here is that a container is sort of like an operating system in and of itself. There's a lot of other extra stuff. So if I Control-C here, and if I say, instead of running that, I say, let me run interactively. Let me remove the ports. Let me run bash here. Oh, right. I need to look at my Docker file, and the entry point is Python, so I need to change the entry point. I have entry point, there we go. So I'm gonna say Alfredo Deza / Flask app. It's docker run. There we go. So now I'm inside of the container. Sorry about that. So the thing is that now I'm running interactively. I'm inside of the container that I just built. If I look at requirements.txt, that's a Flask 1.1.0. If I do app.py, everything's in here. But this is almost like an operating system, right? So if I do cat etc host, which is a good way, no, actually, let's see, OS release, which is a good way of finding what operating system I'm running, we can see that this is based off of Debian and version 10. So it is Debian, right? So I have a bunch of different things here. We can say, let's see what type of Python versions we have installed. So if I do Python 3, Python 3.8.9 is there. I bet Python 2 is there, so Python 2.7. So now we're finding things that I didn't explicitly install. I didn't request Python 2.7. I thought, as a developer, creating this Flask app, that I was just going to use Python 3.8, but surprise, I have 2.7 in here. Well, the reason for that is that the Python Software Foundation, who is in charge of producing these images, says like, yeah, it's probably useful to include Python 2.7 there, and let's just do that. But I had no idea. So now we're finding certain things are there. If I go and say I want to look what it's in bin, there's of course a plethora of software already installed. What versions are those? Like, I'm not sure. What's a good way of keeping track of what's installed in here? I don't know. So that's where the software bill of materials comes into play. It can accurately catalog every single package, every single piece of software at what version and from what source came from. And that's what something like Sift provides. So let's go back to the website where we go. This is the Sift, it's Anchor. This is on GitHub, so github.com/anchor/Sift. And I'm going to scroll down. CLI tool and Go library for generating a software bill of materials from container images in file systems. Let's take a look here how to install it. I'm using OS 10, so let's go and find the installation. Here we go, OS 10 and Linux. You can use. I'm just going to use Homebrew, so I'm going to use these two commands: brew tab anchor/Sift, and then brew install Sift. Back to the terminal. I'm gonna tap it. Oh, it's going to update Homebrew. That hopefully doesn't take too long. Sometimes it can take a while. I have a bunch of different things there. All right, that didn't take that long. And now I can do brew install Sift. So I type that, it goes and fetches Sift, in this case 0.14.0 for OS 10. And in a few seconds, I should have it here. All right. So I can do Sift version. And I think it is actually, this is actually happened because I have it installed in my path. So let me remove that one. So because I've been developing with Sift, I've put it in there, but there you go. Now that user local bin Sift is the one that was provided by Brew. So if I do Sift version, there we go. So now we have version 0.14.0. This was built in March of 2021. Perfect. I get a bunch of information. So what are some things that I can do with these? So if I type in Sift help without any arguments, you can see that you have a lot of different things that you can do here. You can scan either a specific tag, we will do that in a second, or a path to a project. So you can also go into a directory and look at what the contents are of this directory and catalog every single thing that it finds. Perfect. So that doesn't answer the question, what do I have installed in my container that I just built? So we looked into it and we saw a bunch of stuff installed, but I want a complete catalog of everything that is installed. So I'm going to clear my terminal here and I'm going to run Sift. And I'm going to say Alfredo Deza /Flask app. And so I'm going to run these. And the idea here is that this will go into the container, grab the container and start analyzing. Hit return. It's loading the image. This is a fairly large image, so it will take a second. It's a very heavy-weighted container because it's Python 3.8. It's heavy. It has a lot of stuff in there. But I'm sort of like spoiling the surprise. Why do you think it's heavy? Why do you think this container weighs a lot of a lot of gigabytes or megabytes? And that's because, well, it has a lot of stuff installed, and the answer is going to come when Sift produces the bill of materials. All right, so just a couple more seconds and it's loading the image. So there's a whole process going down the pipe because it has to fetch the image from the Docker container. All right, so it finished. Let me scroll back up. So there is a lot of stuff. Oops, I went too far. There's a lot of stuff going on. 442 packages. So a good thing is that Sift can tell you the type of package that you have installed. So in this case, Flask came at the top correctly at 1.1.0. And you can see that Sift detected that this is a Python package. And then all of the dependencies that came with Flask, which are Jinja 2, Markup Safe, and Worksoak. Those are all Python stuff. ArcParse is surprising. Click does come as well with Flask, which is pretty useful. And then you can see that there's some system dependencies, right? There's autoconf and stuff like that. So this gives you a good idea of exactly what's installed in this image. And why is this useful? Well, there's a bunch of different reasons why this in particular is very useful. But I could unknowingly be adding some libraries that I don't want to have in there, that have a security constraint against. So say, for example, I'm going to pick anything here. It could be libdb5 and say, well, in our organization, we cannot have libdb5 installed in any container. Well, something like this could allow you to detect some container that is being built with libdb 5.3 in this case, and then you can say, hey, we're gonna gate on these and we're not gonna allow containers to get into production with that library in there. It can also help you have a good, thorough idea what are all of the packages that you support that are currently in production, even before they go into production. And that gives you a better overall picture of what do you have and what's the overall context of everything that you have in production. So what we saw is the way of a table presenting output of Sift. There's one way. This is going to take a little bit longer. Well, this is going to take as long as before because I'm gonna run again. I'm just gonna run it there. I'm gonna explain what is going while the process is going. So Sift-O JSON will give you an even a more thorough overview of what's going on in here because it is going inside the container, grabbing the same information as before, but the JSON reporting is more detailed. It has absolutely everything that Sift is finding, and we will see how that is presented in a second, and all the nitty-gritty details like how certain packages were found and why, and some information that might not make sense for a table presenting format. But if you want a machine readable format, JSON is perfect. You may have this in a CI/CD pipeline step where you may run these and say, hey, I want to know what's going on exactly in deep detail because I'm going to grab that JSON and perhaps do some processing on my end. And this is going to give a lot of output. All right, let's just scroll just a little bit here. This is about the schema. Look at this. This is too much. Well, it's a manifest over there. It gives you detailed information about the container itself. These are all of the layers. You can see here tags, like all of the tags that were found for this specific image. What's the source? But I want to show you what a specific package looks like, and I think we're getting there. Zlib, there we go. All right, so we have Well, we have an ID. This is an internal ID generated by Syft. We have the name. In this case, is zlib1g-deb. It gives you an accurate version. So both the name, the version, and the type are the three things that are in the table presenter format. But we get more information from the JSON formatting. You can see here that it was found by the dpackage.db cataloger. So that's an internal cataloger from Syft that can detect where exactly this is coming from. And it can tell you the actual location of where these, what the files were that reported that zlib1g-dev is installed in the system. So you have three locations here that are relevant for the package itself. It also detects the licenses. In this case, there's no specific language reported. And you have some CPEs, like the CPE is the Common Platform Enumeration System. It's, or rather, Common Platform Enumeration is good so that other tools can take advantage of this in detecting accurately what's the product and what's the vendor and what's the actual package and what's the version. So it's a good thing to have, and Syft provides those as well. A Perl, it's a package URL, so it's like a good format as well for helping identify packages, and that's provided too, and it's generated by Syft. This is not provided by the operating system. This is generated at runtime. So metadata type, and now we're getting into more like specifics, right? The package metadata. We are getting extra metadata from the package itself. We have the source, the version, source version, architecture, and things that don't make sense to report on the table presenter. And so this is why this is useful. You have all of these paths, all of the files that came with this particular package, and these are all reported here. So again, I think very useful. You can find other reasons as well why this might be critical in your pipeline as you get ready to get containers into production, because this analysis is very thorough. You may be interested in some of the files. Again, having a good thorough picture of what exactly is going on is pretty useful. And finally, once you have something like this and you say, well, okay, I'm gonna update requirements.txt to include something else, and then you do, and then you rebuild a container, then you could tell exactly what changed. Like, hey, if Alfredo comes in and edits requirements.txt and says, hey, he wants to add, say, for example, mercurial, and he wants to say, 3.10.0. As a developer, I feel comfortable with that change, but someone on the operations side might have like a red flag for that. And Python is just one example, but Syft doesn't do analysis specifically just for Python only. It does analysis for everything. And so Mercurial might show up, and that can be caught if you're doing a deep software bill of materials generation, a deep catalog of packages installed under versions. So that is Syft. Again, that's on github.com/anchor/Syft. Very easy to get started. One thing that I didn't show you, I want to quickly show, is that Syft can do also paths. So I can say Syft and I can say dot, I believe. There we go. Yeah, I can do dot. So basically that dir colon, that's a schema that tells Syft, hey, just catalog the current directory, right? So you can see now Mercurial popped in, and you can also do -o JSON, and it'll tell you, it generates the CPEs all over, and now it's caught by Python index cataloger, and the path was requirements.txt, and that was pretty fast. So you are not required to have a running container or like a container being built. You can actually use these for the current path. This is super useful if you're using something like GitHub Actions and you don't want to build a container in a GitHub Action. You just want to catalog exactly what's installed or what would be installed in the system once the container is built. And your requirements that text might not even be in the root of the directory, might be nested. So you might be missing out on something there. And so this takes care of that. All right, so back to the website. It's very easy to get started. You can install it pretty easily. Very straightforward. You have different ways of installing it. Like if you're running a pipeline on GitHub Actions or something like that, you can use curl and install the latest version, or a specific version. In this case, some path and some release. Homebrew is also supported, and you have a bunch of configuration that you can use to fine tune exactly what the output is like. So that's Syft. That's how to generate quickly an SBOM, a software bill of materials. And I hope you find this interesting and you find a way to enable it in your production pipelines.